feedback path and optional divider. Feedback path and optional divider. Most PLL also include a divider between the oscillator and the feedback input to the phase detector to produce a frequency synthesizer. A programmable divider is particularly useful in radio transmitter applications, since a large number of transmit frequency can be produced from the single stable, accurate but expensive quartz crystal controlled reference oscillator. Some PLLs also include a divider between the reference clock and the reference input of the phase detector. If this divider divides by m, it allows us the VCO to multiply the reference frequency of n divided by m. It might seem the simple to just feed the PLL a low frequency, but in some case the reference frequency may be constrained by the other issues. Then the reference difference is useful. The frequency multiplication in a sense also be attained by locking the PLL to the n harmonic of the signal. These may be given a radio transmitter application, since a large number of transmit frequency can be produced from the single stable, accurate but expensive quartz crystal controlled reference oscillator. The equations of the governing phase shift analog the multiplier. The phase detector may be derived as follows. Let the input of the phase be XCT and the output of the voltage be VOC. In is XRT, the frequency omega RT, then the output of the detector XMT is given by XMT is equal to XCT into XRT. Hence the VCO output takes from x of t AR cos value integral, and the equation is given as on the figure. Where the loop filters receive the signals as per the input power produces, where F filter operates representing the filter transformations, and the loop is closed, the output from the loop filter VCO, thus Yt is equal to XFT. We can deduce how the PLL reacts in the sinusoidal input. The output of the phase detector then this can be rewritten into the sum difference components. An approximation to the behavior of the loop filter, we may consider only difference frequencies being passed with no phase change, which enables us to derive a small signal modeling the phase lookup. If we made, then the can be approximated by its argument, resulting in the phase loop is said to be locked if in the case. Thank you.